Cars are one of the most fundamental inventions of our time. Everybody has one, sometimes more than one, and everybody needs one to get around. Now, if you're watching this video right now, then that means you're probably not driving. Hopefully. And if you're not driving, that means that your car battery is slowly draining. Your battery is essential to starting the engine and powering the electrical systems of your vehicle, like the alternator. The alternator's purpose is to charge the battery as the car is running, but if the car isn't running, the voltage of your car battery will decrease over time. That's why for my design project, I have created a car battery voltage monitor circuit. Using an Arduino Uno and several other crucial components, I have designed an efficient system to both measure and monitor the voltage of a car battery. The current prototype is enclosed in this robust green package. The package features two cutouts for powering the system through the Arduino Uno. The system can receive power from your personal device through the USB connector, from a 9-volt battery through the barrel jack connector, or through an AC to DC power adapter that can connect directly to an outlet. The 3D printed housing also features an embedded LCD screen at the front that will constantly display the voltage of your battery and relay any other important information regarding the status of the voltage to the user. On the other side is the input terminal to the system where you would connect your car battery. Now that we've seen what it looks like, let's see how it works. On screen right now, you should see a simple block diagram of my system. At its center, the Arduino Uno. This is a programmable microcontroller that acts as the brains of my design. Connected to it are a few external components like the LCD screen that was just shown. The LCD screen is used to display the voltage level of the car battery to the user. It will also indicate the status of the car battery. The status has 3 different levels. Normal status is when the car battery voltage is between 11 and 14.6 volts. This is the normal operating conditions of a typical 12-volt car battery. Overvoltage status occurs when the battery voltage exceeds the 14.6 volt threshold. Past this level, you risk damaging the system, so try to keep it less than 15 volts as described in the product brochure. Finally, low voltage status occurs once the battery voltage falls beneath the 11 volt threshold. This is when the next component comes into play, the Bluetooth module. The Bluetooth module connects to your personal device. In my case, it's my laptop. Included in the project is a simple script that displays a small GUI on your device. Here, it can read and display low-voltage Bluetooth alerts sent from the module in my design. You are also able to monitor the battery voltage remotely from your device when connected to the Bluetooth module. Finally, that leaves the SD card. While the system is running, the voltage values are constantly logged to the SD card. Once the system is safely off, the card can be removed by taking it out of the housing, which can be accessed by removing the snap-on lid. Overall, the system is very reliable and allows for measurement accuracy of up to 0.05 volts from the true value. Now, before we move on to a demonstration, I'd just like to take a look at the detailed circuit diagram shown on screen right now, outlining all the connections of my design. You'll notice that in the center, just like in the block diagram, is the Arduino Uno. Now, connected to it on the right-hand side, you can see how the car battery actually is implemented into the diagram. You can see that when connecting the car battery, it actually connects to a voltage divider through R1 and R3, which are 5.1K and 10K ohms respectively. As the analog pins of the Arduino Uno can only handle up to 5 volts and the car battery is 12 volts, there needs to be a way to step down that voltage so that it can safely connect to the Arduino Uno. For this, I used a simple voltage divider that steps down the 12 volts to the 0 to 5 volt range, and then within the programming of the Arduino, the true voltage value is recalculated and then displayed on the LCD screen. On the left-hand side, with the Bluetooth module connected to the RxD pin, that is the receiver pin, you can see that there is another voltage divider connected to it. That is because the receiver can only receive 3.3 volt signals. However, the signals coming from the transmit pin, the D1 pin on the Arduino Uno, are 5 volt signals. So another simple voltage divider shown through R5 and R7, who are 2K and 1K ohms respectively, was done so it can step down the 5 volt range to the 3.3 volt range. All other connections are very straightforward and simple, with the SD card connecting directly to the digital pins D10, D11, D12, and D13 of the Arduino Uno, and all of the external connections from the LCD screen are connected to D3 to D8 of the Arduino Uno. But I think that's enough explaining. Why don't we see a demonstration with a DC power supply? So what I have here is that this is my finalized package. On the front, I have the LCD screen embedded, so this is going to be used to locally display the voltage values of the battery. On the side, we have two cutouts here for accessing the Arduino Uno. And so there's two. One on the right is to power it with the AC to DC power adapter. So from an outlet, which is right here, this guy. So this guy I'm gonna plug into the outlet over there. That's gonna be used to power my Arduino. But you can also access the USB port in case you wanna power it from your laptop or just access the Arduino in general, because you're gonna wanna plug the Arduino into your laptop when you read the voltage values that are logged to the SD card that is connected to the Arduino. And on the opposite side, there is one last cutout with two wires here. Now these are just used to connect to the car battery and actually read the voltage value. And on top, we have the lid, which is labeled, says ECE 5000, car battery monitor, Cameron Tavaroff. And now I can also open this up so you can see the interior. It's a little bit messy, but it all works. So we have the Arduino Uno on the right there. We have two PCBs that have been soldered together. So right here, this component is the Bluetooth module. So this is going to be used to send alerts to my laptop over here. And underneath it, there's another little PCB. It's kind of hard to see, but it's down there, and that is where the SD card is mounted. And then of course, on the back here, that's where the LCD screen is. So now what we can do is power this up. So I'll take my power adapter and I will get it into the outlet back here. And then take the other end, the barrel jack connector, and we'll plug it in just there into the Arduino, like that. So now I've just powered it, and it turns on and it says the initializing is successful and it shows low voltage. So right now there is nothing connected to my input, so it shows 0 volts now. And that is low voltage because my low voltage threshold for my system is 11 volts. So because it's beneath 11 volts, it's considered low voltage. And obviously this would be low voltage since it's not connected to anything whatsoever. So the next thing I'm going to do is come over to my laptop and I'm going to run my processing sketch here that I wrote in Java really quickly. And now this should connect to my Bluetooth module and display in a small GUI the voltage. So right now, because it's low voltage, we are getting a low voltage alert, 0 volts. So this is my low voltage alert system. So we can tell that my Bluetooth module is working correctly. And if we want to confirm, I can come to my Bluetooth on my laptop and I can see here that the HC05 module is connected. HC05 is the Bluetooth module that I'm using. So I know that it is working correctly. So I'll have that open here and we'll look at 3 cases in this demonstration: the low voltage case, which is now being demonstrated, the normal voltage case, which is the case where the car battery voltage is above 11 volts, but beneath 14.6 volts. And then the final case where the car battery voltage is above 14.6 volts, which would be an overvoltage scenario. So the first thing that I'd like to demonstrate is connecting this to an actual battery. So here you can see that I have a 12 volt, 7 amp hour battery. And I'm going to measure the voltage on this and see what we get and how this updates. So give me a moment to connect that. So I have just wired it up. All I have is just the leads touching for the time being, just so there's a connection that I can use right now. And if I look at the LCD screen here, it says that the voltage is 11.88 volts and the status is normal. So this is a 12 volt battery. Batteries are typically never at the magnitude of their rated voltage, so it makes sense that it's close to 12 volts, but not exactly 12 volts. And you can see that because it is above 11 volts, the status is normal. So now also, if we switch over to the processing sketch, the GUI here, it reads 11.9 volts. It rounds a little bit. There we go, 11.88. It just updated. And we get the status normal here too. So we can see on 2 fronts that this is working properly. So now you can just look at this and see how it updates as I disconnect the wires, just so you can get a good demonstration. So now it's off. Give it a quick second here. 0 volts, low voltage. So it updates accordingly. And if we go back, we can see 0 volts, low voltage. So everything is working great so far. And it works with an actual battery. So that's kind of the main point of this project, the main goal. So now what I'm going to do is that I have a DC power supply here where I can change the voltage, and I'm going to connect this DC power supply with these alligator clips to my design. And then we're gonna just mess around with the voltage a little bit and see how my design responds to different voltage values. So give me a moment to connect that now. Okay, so I've just connected the DC power supply to my design, and you can see that it still says 0 volts, but that's because we are currently not outputting anything. You can see that the light is not on. But as soon as I hit the output button here, it will receive 10.2 volts. So let's turn that on. So we got 10.3 there now, and if we come back here, 10.26 volts. There we go. So it's actually quite accurate. It might even be more accurate than the DC power supply here because it has more precision. It has more decimal places. Here we only have 1 decimal place, 10.3, but here it's calculated to 2 decimal places, so we get 10.26. So very, very close. And we still get the low voltage alert because, as I said, the threshold is 11 volts. So if I come here now and I adjust this knob and just bring it slightly above 11 volts and we come back, 11.5, we got 11.5 volts on the dot, and the status is normal. So this says exactly 11.50, and right here we have exactly 11.5. So it is working very, very nicely. And we can transition it to different values if we want to. We can go really low. We can go down to 3.8, see how this responds to it. 3.79, very close. And we can come back here to the Bluetooth alert, and it says 3.79 volts, so it's working very, very nicely. Now there's the case where the voltage is above 14.6. So from my research, I discovered that when the car is running, the alternator of the car can overcharge the battery past 12 volts, typically up to 14.6 volts, which is why my design is made to be able to read up to 14.6 volts in case your battery is overcharged in such a situation. However, if you exceed 14.6 volts by connecting some power supply that provides voltage greater than that value, you will get an overvoltage alert, as this could damage the system. So we're going to demonstrate that now. So if I increase this all the way up to, let's do 15 volts. If I come here now, it says over voltage, which is exactly the alert we're trying to see. And if we go here, we can also see the over voltage also shows up on the Bluetooth alert. So this is really important because if you continue to increase the voltage past this point, it could damage the system. So now again, if I go slightly lower, like 14.4 now, this should adjust and we get 14.38 volts. Status is normal because it is greater than 11 volts, but less than 14.6 volts. So that is the full demonstration of my design. So to recap, what was done is that I am doing a car battery monitor for the voltage of the battery, and how I demonstrated that was by connecting my design to an actual battery and read the voltage. And so we had 3 major cases: the one where the voltage value is under my 11 volt threshold, which would be low voltage, which is what we have right now. Then there's the case where the voltage is between 11 and 14.6 volts, and that is when the status is normal. And then there's the case where the voltage is greater than 14.6 volts, and that is the case for over voltage. So those were the 3 different scenarios that were demonstrated, and my design worked properly for each and every single one of them. So that is my final demonstration. Thank you for listening. Okay, so I'm outside right now, and I have my design connected to my car battery right now. So I have the positive connected to the positive terminal and the negative just connected to a piece of metal. And if you look at the front here, it reads 12.68 volts, so everything is working normally.